technological advancements are transforming our everyday life, and the field of wildlife research is no different. Drone technologies are transforming how we're monitoring animal populations, from nuisance or invasive species to threatened and endangered species. And these population estimates that we get from these drone surveys are helping us to inform important conservation and management actions. However, these drone technologies do have a few limitations, including limited battery life of only about 30 minutes, as well as limited regulations in terms of visual line of sight. So pilots have to maintain that visual line of sight with their platforms at all times. And due to this, new drone survey designs have been implemented, one of which is shown here on the bottom left. It's called a lawnmower pattern, where we go up and back across our survey area and take a multitude of images, shown here by those red dots. And each of those images is often overlapping, so one image is taken on top of slightly that subsequent image. However, this is done to have computer software that can then stitch those images together in what's known as an orthomosaic. And I predicted in my research that these image overlaps would likely lead to overestimation of animal counts, which would be critical for informing our management efforts. So to test this and to quantify any of that sampling error, I use computer modeling. And so I used an agent-based modeling approach in the Python programming environment and ran thousands of simulations on a supercomputer here at Mississippi State. Essentially, I created a video game where I could use literature-informed animal movements and programmed different drone survey patterns into these computers to replicate thousands of times and see how much sampling error we got. And so when we had a solitary mobile animal within the survey area, we found that those image overlaps do in fact lead to overestimated counts. And we recommend that drone practitioners use no or minimal image overlap when they're doing their surveys to reduce this sampling error. When I added multiple animals onto the survey area in different densities, I found that when these animals were grouped together or clumped on the landscape, mimicking flocking or herding animals, that we also had less precise counts. And so we recommend that drone practitioners utilize either a space transect design or, using this lawnmower flight pattern, sample at least 50% of their survey area of interest to extrapolate that count. And even when we added movement to these multiple animals and distributions, we found similar results and recommend these practitioners use these same survey patterns, overall informing greater conservation management of these important natural resources.